This lesson is an introduction to the concept of threads, which begins an explanation of Java animation, one of the things that you can do with threads. We've looked into the fundamentals of drawing still pictures in a window, but Java also contains the things you need to make the pictures move. All of the programs that we've looked at so far have been single-threaded. In fact, most programs are single-threaded because they only need to ever do one thing at a time. A windowing program is usually single-threaded because 99% of the time it has thrown up a window and is waiting for you to respond to it. Your response is in the form of a mouse click or typing some letters on the keyboard. All the time you're doing this, the program is, for all practical purposes, stopped in its tracks and doing nothing other than paying close attention to the input you're giving it. You may click on an OK button or something, instructing the program to do something, so then it throws up an hourglass cursor and completely ignores you while it runs off and does the job you requested. Once it has finished, it may or may not tell you what it did, but it comes back and waits for you to give it some more input. If something is wrong with the program, it may go off and never come back. You've had this happen, where a program just quits responding to you. The only thing you can do is kill the program. The operating system doesn't know what the program is doing, so you may get a warning about losing data or some such, but you kill it anyway, knowing that you can come back and pick up the bodies later. But it doesn't have to be this way. It's possible to have your program do a separate job in the background while it's paying attention to you. You've used a word processor or something that requested that it send something to the printer. Nothing happens at the printer for a few seconds, but control is returned to you immediately. Sometimes a window pops up asking you for printer options, but as soon as you answer the questions and click OK, the printing process is off on its own in the background. You can continue to edit or whatever as the word processor spools out the data to the printer. In this scenario, the print spooling is done by a thread. Ultimately, the printing itself may be done by a separate process, but that's another thing. What I'm talking about here is the same program doing two things at once. While the main thread is waiting on the mouse, a separate thread is off doing some special chore for you. This threading is not limited to just one background task. There can be several of them at once. A simple example would be a web server. You have your website on a server and several people address it with their web browser all at once. Each visitor to the site can get their own thread running, and each one can go their separate ways through your web pages. There are other ways of doing this, but I hope you get the idea. The whole point is that you can have your program do several things at once. Same program, different tasks. You pick the class that you want to be able to execute in a separate thread, and you implement an interface named Runnable for it. The Runnable interface requires that you have a method named Run. And it's this method that will be called by the thread. That is, when you start your thread, the thread will call this run method, and you can do anything you want to in that method. However, once your run method has finished and returns to its caller, the thread quits. So inside the run method, you must complete whatever chore the thread is supposed to do. You must create a thread object specifying an object of the class that implements the runnable interface. This has the effect of establishing the existence of a new thread, but nothing has happened yet. To start your thread running, you simply call the start method of the thread object. This causes the thread object to leap into action, split itself off into its own private thread of execution, which has nothing else to do, so it calls your run method. You could actually create any number of threads on the same runnable, but they would all call the same run method, and it would be up to you to sort out which task each one is supposed to do. It may be more convenient in a large program to create several runnable classes and then start threads on a specific class depending on the chore to be done, but I'm getting ahead of myself. Anyway, that's all there is to starting a thread. The next lesson demonstrates exactly how this works with a simple example.